the largest solar radio imaging telescope circular array is now complete. The Circular Array Solar Radio Imaging Telescope was built in Daoqing, Sichuan. It is currently the largest comprehensive aperture radio telescope in the world. The construction site of this project has an elevation of 3,830 meters and covers an area of 100 acres. The Sichuan Provincial People's Government has allocated 30 million yuan of local financial funds for infrastructure construction. 313 antennas with a diameter of 6 meters resembling pot covers are evenly distributed on a circular ring with a diameter of 1,000 meters, forming a unique circular array. Using the original single-channel multi-ring absolute phase calibration technology, the calibration tower at the center of the ring, which is 100 meters high, provides the calibration reference for the entire observation link. Its shape is likened to a huge, thousand-eyed celestial sphere, by locals, playing a crucial role in the entire solar terrestrial connection chain of the Meridian project. It is the largest and most powerful solar radio imaging telescope in the world. Each antenna that forms the thousand-eyes Tianju rises from the ground around a 100-meter high calibration tower in the center of the circular array, like 313 sunflowers, constantly rotating in the direction of the sun, gazing at the vast universe and exploring the sea of stars, observing the sky day by day only to unlock the secrets of more space and energy. This landmark project is planned to be implemented and facilities will be completed, in conjunction with the Cosmic Ray Observation and Research Center, the Large Optical Infrared Telescope, and the Heizishan Celestial Park, laying the important position of Daoqing and even Ganzi Prefecture in the world's astronomical scientific research industry. Create a world-class astronomical tourism destination in Daoqing County and surrounding areas that integrates astronomical and cosmic exploration, plateau ecological tourism, and Kangba cultural experience. Human observation of the Sun has a long history and rich methods. There are not only high-energy X-ray, ultraviolet, and visible light observation methods on satellites, but also visible light, infrared, millimeter wave, and radio telescopes on the ground. However, there is a lack of observation capability in the low-frequency band, such as the 150 to 450 MHz frequency band, which can only be observed by a telescope built in France in the 1980s, and its sensitivity and resolution are far from meeting the requirements. In addition, due to the rotation of the Earth, this radio telescope cannot continuously observe the Sun and cannot meet the requirements for observation time zone coverage. The Circular Array Solar Radio Imaging Telescope, DSRT, has completed this gap. It can observe the radio radiation generated by solar flares and coronal mass ejections, synthesize continuous videos through radio image sequences, monitor the formation and evolution of these substances emitted by the Sun, study the process and mechanism of solar eruptions, determine the speed and direction of coronal mass ejections, and help scientists study the laws and mechanisms of solar eruptions, analyze weather and when coronal mass arrives on Earth, predict whether space weather events will occur. The reason why this band is important is because during the process of ejecting coronal matter from the solar atmosphere into the interstellar space, the shock wave-driven radio radiation is located in this band. In this band, the radio radiation that occurs in the high corona several solar radii from the Sun's surface can be monitored, which also determines the shape, structure, and direction of motion of coronal mass ejections into the interplanetary space. Where is a good place to look up at the starry sky? The compound eye is located in Chongqing, the heavenly eye is located in Guizhou, the Qinyan Tianju is located in Sichuan, and the western region seems to have become a concentrated area for the construction of astronomical observation facilities. Firstly, the western region is relatively dry, with more sunny days and less water vapor, which is beneficial for optical telescope observation. Secondly, in the western region, there are few cities and electromagnetic interference, which is beneficial for radio observation. In addition, there are many high mountains and plateaus in the western region, which have high air transparency and are more conducive to observation. Qinghai, Xinjiang, and Tibet in China are all suitable for building observatories, especially the Qinghai Cold Lake Observatory site, which can be comparable to the best international observatory site. The location of these astronomical facilities also provides rich research resources. At present, the Chinese Heavenly Eye has been open to the public, allowing for a close-up view of the world's largest radio telescope from the observatory. In addition, there are astronomical science popularization facilities around the Daoqing Observatory in Sichuan, and the astronomical science popularization city is also being built in Linghu Town, Shanghai. In addition to watching the observatory, many places in the West can also watch stars. From the 24th day of the lunar month to the 6th day of the following lunar month, far from the city, on clear nights, you can see stars all over the sky. Occasionally, you can also see meteors and artificial satellites, and even see the Chinese space station crossing the sky. The larger the antenna of a radio telescope, the higher its spatial resolution. Although the diameter of the DSRT antenna array is only 1 kilometer, the use of a comprehensive aperture imaging method theoretically doubles the electrical size and doubles the spatial resolution of the antenna. What is the comprehensive aperture? This requires the use of a comprehensive aperture imaging method, decomposing a large lens into many small apertures, each of which synchronously receives external signals, and then adding all the signals received by the small apertures together is equivalent to a large aperture antenna. In order to fully release technical risks, the project team adopted a 3-step construction plan. The first step is to test the water by building 2 small antennas and conducting system development. The second step is to verify and build a more complex 16-seat antenna system, and carry out verification and development. Finally, the construction of the 313-unit large system was initiated. The first 2 steps will be completed in August and December 2021, respectively. During this process, Wu Lin and colleague Yang Yang coordinated with various outsourcing units to investigate and solve hundreds of technical problems, from prototype development to joint debugging and testing. When the 16-unit verification system was built, the number of antenna units was only 1/3 of the international observation equipment in the same frequency band. But its observation results for solar active regions are already superior to those of its peers. In this way, the overall functionality and performance indicators of the system have been verified, and the technical risks of large-scale system construction have been fully released. Observing the sky day by day, exploring the stars and the sea. Telescopes can perform tomographic imaging of the outermost layer of the Sun, obtaining real-time real images of the Sun and CME radiation, which will have important reference value for space environment, space weather monitoring, and related forecasting. The Thousand Eyes Tianju is mainly used to capture the Sun's sneezing, which is a high-precision imaging observation of solar eruptions. The solar outer atmosphere, corona flares, plasma, and high-energy particle streams released by ejections can have serious impacts on the Earth's space environment, damaging satellites in orbit, disrupting the Earth's power grid, and radio communication. The energy released by a strong solar eruption is equivalent to the energy of 10 billion million-ton atomic bombs. The Sun is about 149 million kilometers away from Earth, and these high-energy particles take about tens of hours to reach the Earth. When the Sun experiences a violent eruption, high-speed plasma will appear on different frequency bands of electromagnetic waves, which only take 8 minutes to reach the Earth. Therefore, through observation, it is possible to predict whether the solar eruption will reach Earth 1 to 3 days in advance, as well as the timing of its arrival, and to make targeted space weather forecasts and warnings. During the day, you can look at the Sun, and at night, you can also see the stars in the Thousand Eyes Tianju. In March 2023, the scientific research team of the National Space Science Center of the Chinese Academy of Sciences successfully obtained the continuous radio image sequence, identified the pulsar J0332 plus 5434 flickering in the image, and the positioning accuracy of the pulsar reached 1.8 angular minutes, which preliminarily verified the ability of the Thousand Eyes Celestial Pearl for pulsar detection.